We'll start with that by just do a quick overview on the Cisco website. So what are the components that the Cisco UCS system is about? Well, like I said, we are focusing on the CCIE data center test. If we look at the blueprint for the CCIE data center test, we will see that we have all components that I will show you here. We have those on the blueprint. So we have the B series, the C series, the fabric interconnects, extenders, the UCS manager, several types of I/O adapters that we can insert into blades, and all kinds of other things. So you will see everything on the blueprint. But what do we really have in the CCIE data center test? In the CCIE data center test, we have a couple things. So the first thing we have is that we have blade systems. So we have blade chassis, probably one chassis, with a couple blades, different blades in it. And we will also have rack servers, but they will not be integrated into the UCS system. And what I mean with that is, we'll talk about that a little bit later. So we have a blade chassis, we have a rack server, but this rack server you have no access to. Now that's fun, right? So it's on the blueprint. This is, by the way, the C series servers. So, but those rack servers, you do not have access to them. In no way. What that means is they are used for testing. And usually for FCOE testing, so fiber channel over Ethernet testing. These servers will be connected to some switch ports in your data center network, and you will be configuring fiber channel over Ethernet connections and other Ethernet connections just to allow certain types of traffic towards that server. But you will never be able to access the management tools or the server itself. So that's a very important thing to remember. No access to the rack servers, only towards the blade servers. And also for the blade servers, you have no access to the operating system. It runs an operating system, probably VMware ESXi, but you will not have access to ESXi. So there's no VMware in the CCIE data center test. So they say it's a Cisco test. So why do we need to give you access to the VMware products? It's a Cisco test. We only test you on Cisco hardware. So a very important thing to remember there. No access to ESXi, no access to the rack servers. So all I have access to is my UCS manager, all the components, the CLIs and stuff. Of course, I can show the KVM session of the blade, but we'll touch that in a later stage. So important things to remember here. And apart from blade servers and rack servers, we have some other components. We have something called a fabric interconnect, or FI for short. We have fabric extenders, although in the UCS they are usually called I/O modules. So if you hear me talking about a FEX or a fabric extender or an I/O module, I mean the same thing. I usually talk about an I/O module or a FEX, depending on the thing. Then we have different adapters. So I/O adapters in the service itself. And we have, of course, different types of blade servers. Now, as I said, I will not make this a very hardware-related class. So if you go into the B series blades, you will see there are tons of different models and versions of the different models that you will see. This changes in days. Every day there can be a new model. So depending on the CPUs, depending on the memory requirements. So if Intel releases a new CPU, probably in the next 1 or 2 months, Cisco will release an update on their blade systems and will integrate that. Depending, of course, on new sockets and new memory requirements and stuff. But to start, the UCS system hosts Intel blades. Intel x86 blade servers. And this is not, I get a lot of questions from customers for, all right, so Cisco makes servers, so who really makes them? Is it an HP or an IBM or a Dell server? Like they did with the call managers in the past. This is really Cisco hardware. Cisco makes these machines, and of course they borrow or use components from other vendors like Intel, like Broadcom, like all kinds of other vendors, but they do make their own boards, they do make their own hardware related things, and they use merchant silicon for that, and of course they use Intel CPUs. So that's one thing. On the networking side, they do run their own hardware. So of course Cisco, the networking company, Cisco really uses their own network interface cards and fiber channel adapters in those servers. So it doesn't have to be a Cisco adapter, it can be a QLogic or an Intel adapter or NIC, but usually you will see in most deployments you will see Cisco adapters used. In the lab, in the CCIE data center lab, you will see both. You will see both Cisco adapters and the merchant adapters, so the Intel NICs and the QLogic HBAs, for example. So those are the blades. There's one type of blade chassis, so the system always hosts these blades in a chassis. The chassis there's only one version of, which is the B5108 blade chassis, and that is an 8-slot chassis. So if we draw a little bit about that, like I said, we have all these blades, so they run independently, or at least they run their own CPUs, their own memory, their own network interface cards, but they need to be hosted into a bigger system. That's the whole thing about running blade servers. I want to run a high density of servers in my rack, so I need a system to use that. So there's one big chassis called the B5108. This is an 8-slot chassis, of which I can fit 8, as they call it, half-width blades. So if I divide this into 8 slots, so I have 8 slots to fit 8 different blades, but I do have blades which host more memory. So let's say this half-width blade has a limited amount of real estate, so just physical real estate, that I can fit DIMMs and that I can fit CPUs. So I can only fit like a dual socket CPU here, so I can fit 2 CPUs maximum in a half-width server, and I can host an X amount of memory. Of course that changes over time when new memory is released, when higher density memory is released and stuff. So if you want more memory, Cisco makes bigger blade servers. So this is what they call a half-width. So they consume, this is 1 slot in the chassis. And it hosts, like I said, dual socket, its own memory. And it hosts 1 NIC, so 1 adapter. And they call that mezzanine adapters, or MES adapters. These MES adapters are the converged network adapters. So either my network uplink, my fiber channel uplink, but usually a combination of the two in a converged network adapter environment. So I usually see here 1 CNA, as they call it, for both my networking and my fiber channel uplinks towards my network. So that's the mezzanine adapter, or mezzanine slot, mezzanine card, how you want to call it. If I have a full width blade, meaning I consume 2 slots in the chassis, so the full width, this consumes 2 slots. If you look at the chassis again, so I can mix and match this. So there's a bridge between these 2 slots, which I can remove, and then I can fit a full width blade, like in the next one, which I can mix and match. I can mix half width slots, and I can mix and match a full width slot. So I can insert 1 big full width server here and 2 half widths here, and same here, and another 4 half widths down here. How does that work with slot numbering? Well, of course, this is slot number 1, slot number 2, slot number 3, and then slot number 4 is now equipped with another server, right? It's the same server, but this will be number 3. So it's always the left side of the chassis, the number there. So the odd numbers are on the left side of the chassis and the even numbers on the right side of the chassis. So a full width blade always has an odd numbered slot. So this is then 5, 6, and then 7 and 8. So if I insert a full width, I lose the even slot number which is connected there. What do I get for that? As I said, more real estate. So I can fit more memory DIMMs, I can fit more CPUs, I can fit more local hard disks, because I have more space, physical space on my blade. But what I also have is now I have 2 mezzanine cards. Because behind each of these blade slots, there is one connector for a mezzanine card. So if I have if I host it in 2 slots, I also have 2 connectors for my networking. So I can fit multiple network cards in my full width blade, and therefore I can scale the amount of networking and the amount of bandwidth that I have on my system. So full width blade is also capable of running more bandwidth to the system. Now, and like I said, there are various different versions of it. Let's look what's currently on the data center blueprint, so CCIE data center software versions. Then you also see the hardware related stuff there. So let's run it here. So what do we have? What does it say here? It says we have that B5108 blade chassis. We have B200 blades. Well, that's very vague because there are 3 generations of these blades, all having their own separate physical properties. So, as said, we are running a B200 blade. That also means that we do not have full width blades. A B200 is always a half width blade. But a B200, I can have that in an M1, M2, or an M3 version. Be prepared to see all 3 variations. Actually, the M1 is already end of life for a long time. So they used to have the M2s. So if you take your lab, the availability of CCIE data center lab seats was very limited in the beginning. They only had 2 or 3 seats, and they were not available every day. So there was a lot of complaining about the amount of seats available for the CCIE data center lab. So they added new racks recently. So that's like in 1 month ago. They added more racks both in the US and in Brussels. So I think the racks are in RTP or in San Jose, either one. But in the US they added 1 or 2 racks, and they added 1 or 2 racks in Brussels. Because the M2 is also end of life, or end of sale, it's not end of life, it's end of sale. The CCIE team purchases hardware from Cisco. So they now had to purchase M3 blades. These two have different options when it comes to networking. And I will point that out in later today. So we will need to be aware what kind of blade we're running. Are we running an M2 blade or an M3 blade? Because we can fit different networking options on there. And there's a very good document from Cisco about this. What kind of networking options I have on this M3 blade, because this is really the next generation of blades that they're using, and that has a lot of different options for its networking and how I place different things and how I scale it. So be aware if you're running M2 or M3s in your rack in the lab. They might not use the M3 features, but they are not limited for doing it because the blade is supported. So I want you to be aware how things work, and especially when things come online. So we'll focus about the differences between the M2 and the M3 blades. Because they are running, this is a pretty recent hardware. So because they're running in that new rack, because they're running those M3s, they had to change the software versions that they use. In the past, if you compare the old blueprint, it said UCS software release 202Q or 202M or P or anything. It showed 2.0 and then a specific version. Currently, they specify it as 2.x, which is very dangerous. Because of course, if I go back to my if I have a 2.x version, like I said, they used to have 202 and then some code. I think it was Q, 202Q. This was a very specific release that they're running, but this release doesn't support the M3. So the M3 blade, the physical drivers were not available in this software release, so they had to upgrade the release that they're running in the lab. currently they're running some 205 version. I'm not exactly sure which specific code version, but the 205 does support the M3 blade. And of course some minor other things, but the 205, the biggest difference is the support for M3 blades, and it runs in Java 7, which is good for your client PC, but you do not need to worry about the Java version in the lab, of course, because it will work. So 205 is the current version, but because they specify 2.x, of course they can also run the latest version, which is 2.1, and then 2.1, 1, 2, or 3. So currently we are at 2, and I think they released 2.13 yesterday. So they could test 2.1, and in 2.1 we have very different support for a lot of software features. 2.1 changed a lot about the UCS system, and especially coming to a CCI lab, you want to be fully prepared for the software version. So technically they could run the 2.1 release, but they said on the Facebook group, actually, there's a guy from Cisco who works in the CCI data center team, or at least helps them. He said we will not use 2.1 without explicitly telling you so. So be prepared for a minor upgrade, which he meant to 205, which has support for the M3 blades, because we had to buy the M3 blades. We could not buy the M2s. So we just upgraded to 205, and of course I like to run 2.1, he said, but we cannot do that because that's a change on the blueprint, letting people prepare very differently. And we need a 6 months time ahead of that. But don't be surprised if they do announce that and introduce that very fast, because it's technically not a blueprint change. It's just a slightly different change, but it does require you to test, to be prepared for a lot more features. But this is the version that you will see in the lab, 205. And also how you see it in our real rack rental. In the simulators, I think we're going to use the 202Q, because technically, in feature-wise, there's no difference here. Just support for hardware. So again, be prepared for the M3. What else do we have inside our blade chassis? Well, we have things called like a Palo card, and we have an Emulex card. Now, Emulex is just a vendor who makes converged network adapters. So there are 3 options. When you order a UCS blade, I need to select which CPU type I want, how much memory I want, but I also need to select which mezzanine card I want. So as said before, the Mez card is the networking card in my UCS blade. And networking, I mean both storage and Ethernet networking. So this is the networking part of my blade. And that can be a pure Ethernet NIC, or it can be a converged network adapter. You can choose an Ethernet NIC from Intel, which just has 2 times 10 gig upwards to the network. So no issues with that, just a normal Intel NIC as you are used to buying in your servers. Or I can buy converged network adapters. And these guys run FCOE. Running FCOE up until the management point. We'll talk about that later. So this is a converged network adapter that I can buy for my normal server as well, with also 2 times 10 gig uplink, depending on the adapter that you buy. It can also have a 4 times 10 gig uplink. But let's assume we have a 2 times 10 gig uplink here. So we are running a CNA. Either way, we're running the CNA because we have the Palo card and the Emulex card. Now, if I buy a CNA, I again have 3 options. So I can buy an Emulex card. I can buy a QLogic card. Both just third-party vendors that made a specific card that fits into this UCS service. It's not a PCI Express slot or anything. It might technically be it, but it's a different form factor. So you need to buy that specific card for it. Or I can buy a Cisco adapter. So Cisco creates its own converged network adapters. And of that Cisco adapter, there are a couple options. Again, so the tree grows here. So I have so they all are called Palo cards. And these cards are called Menlo cards. So if you have any guy talking to you about Menlo cards, they purchased third-party chipsets on Cisco's own form factor. A Palo card is Cisco's own CNA. so Cisco's own converged network adapter. That Palo card used to be one card, which is called the M81KR. That's how it shows up as a model type in your UCS. So if you see a Cisco M81KR, that's your Palo card. But there are more. There's also a VIC 1240 and a VIC 1280. And for the VIC 1240, I can also buy a port extender, or port expander, I think. So again, a lot of options. In the first release, this was the Palo card. So the M81KR was the Palo card. But it could very well be that your B200 M2 or M3 blades are equipped with that newer VIC 1240 card. And there are some changes in that. So if I look up that document that I have, there's this spec sheet, it's called, for the B200 M3 servers. And as I said, going back to my M81KR, if I just have my blade server, so blade 1, it just has 2 times, so a 10 gig E left and a 10 gig E right. And this is 10 gigabit Ethernet and fiber channel over Ethernet. So this runs both Ethernet and a special VLAN for FCOE. Then the VIC 1240 card has more options. It can utilize, depending on the hardware that you have in the rest of the system, it can use 4 times 10 gig. So I have a 10 gig link here, I have a 10 gig link here, and a 10 gig link there, and a 10 gig link there. And I can even increase that when using a VIC 1240. And if I have a full width blade that I equip with all kinds of cards, I can get up to a maximum of 8 times 10 gig towards a blade. Now that's a lot of bandwidth going towards a single Intel x86 blade, of course. So it depends a lot if you really need this or not. But there are a lot of options here. So let's look at that document. Going to the network connectivity part. So here I see what I have. So this is my B200 M3 server in what I can fit into it. So I can fit that VIC 1240 card, which is here on the right, but it is not using the mezzanine slot. It has a special slot, a so-called VIC 1240 slot. So instead of just having one mezzanine slot in a blade, in the B200 M3 I have 2 types of slots. I have 2 slots that I can fit something in. So first of all, I can fit that VIC 1240 and then I can add something to it. So going a bit further, how does that work? I need a couple drawings here. So in total, as you can see, we have 2 times 10 gig here, 2 times 10 gig here. So in total we have 8 times 10 gig. Yes. But it depends very much how much bandwidth I really have between the fabric, between the system and the blade server itself. So if I just have the VIC 1240 with nothing else in it, I can use 2 times 10 gig left and 2 times 10 gig right. That's the default if I just buy the VIC 1240, and that's probably how you will see it in the lab. It will probably just have the VIC 1240 adapter in it, where you have 2 times 10 gig on the right, left, and 2 times 10 gig on the right. Now, depending on the rest of the system, this can be port channel, and that's underwater. You do not need to worry about that. That's going to be done automatically for you, depending on what you use. If I'm running a port expander card, like I said, so along with the VIC 1240, I can also add a port expander card. What I do with that is I increase the bandwidth. So I activate my other 4 links, going to each, so go other 2 links to each fabric extender, so to each system component, but I do not increase scalability. Meaning how much traffic can I process here on different cards on that VIC 1240, how much traffic I can process there. And again, depending on the rest of the system, I have a lot of combinations that I can get, but we'll talk about a lot of things later. So be very careful when selecting the server, be very aware what kind of adapter is in your blade. That's what I want to tell you here. So am I running that M81KR? Am I running a VIC-1240? What kind of additional cards do I have? So do I have that port expander card, or do I have a VIC-1280, which is not a replacement for the VIC-1240. The VIC-1280 is just a second card that replaces the port expander. So we have a question, does the VIC-1240, is that a 2 times 10 gig port or a 4 times 10 gig port? The VIC-1240 has 2 times 10 gig on the left and 2 times 10 gig to the right. And that can be channeled together. And I can increase that with adding another card in that mezzanine slot, and then I can increase that up to a 8 times 10 gig. So again, depending very much on if you could have potentially a server running something that requires 80 gigabits of bandwidth. I have not seen a server doing that, but it might be, of course. So the VIC-1280 is also, it fits into that mezzanine slot combined with the VIC-1240. So a lot of combinations that can happen there. Mostly you will see the M81KR used or the VIC-1240 by itself. And again, when using the VIC-1240, there are some things to think about. And we'll come back to that in detail. But if I'm running the Menlo card, I am having totally different capabilities on my system. So very important to know what card am I running. This can show up as an M71KR. So the Palo card shows up as an M81KR, and the other card can show up as an M71KR. And then behind that it will show you if it's an Emulex or a QLogic or anything. So a lot of different combinations here. So I have my blade system. That blade system fits into a chassis, that B5108 system. So those are my 2 first components that I covered. Like I said, this is going to be that B200 M2 or M3 in the lab. Sorry, I'm in front of it. So the B200 M2 or M3 for the lab. And that of course needs to connect somewhere. Now the very important thing to remember in UCS, the blade system does not work independently. So that B5108 does not work independent. It's not an independent system. I need additional components before my blade system can do anything. If I have a C-series server, so that rack mount server, that can run independently. It's just another Intel rack server. There are some special things with it. So in my rack servers, so again, I have my rack server, that C-series blade or C-series rack mount server that has 2 onboard 1 gig ports, like any server would have. It has an out-of-band management port called the SIMC, or CIMC, Cisco Integrated Management Console or Controller. And I can fit in a Palo card. So again, I have some PCI slots in this system, and there I can fit my normal CNAs, so I can buy any QLogic or Emulex or Intel NIC, fit that into my PCI Express slot, or I can insert the Cisco Palo card, also called VIC. This is called the P81KR, or Cisco VIC card. And you probably will see in the lab, the C-series servers in the lab will run that P81KR. It has the same capabilities or the same features as the one in the blades, just with a little bit different scaling limitations and a little bit different functioning, but the idea is the same. The whole concept is the same. So in addition, you will probably see in the lab, you will see these guys inserted into those C-series servers. So we have a question, the card you enter in the blade before you enter the blade in the chassis. That's correct. So, like I said, if I open up my blade system, what I will see is, if I take it out of the chassis, what I will see is I have a CPU, just an Intel CPU, another CPU, maybe, or maybe not. And I will see a lot of DIMM slots, so a lot of things here, a lot of DIMMs, because I need a lot of memory, right? I'm running VMware. And of course some other things, maybe some discs here in the front. And additionally here in the back, I have the mezzanine slot. So this is not something you typically configure yourself. This is you coming from a factory. When you take it out of the box, it has that card installed for you. So, and along with, if I buy that M3 one, underneath here, I have that VIC-1240 slot. So the VIC-1240 fits into a special slot, and I can fit the mezzanine card on top of it, or vice versa. And behind here, I just have all kinds of copper connections that I just fit into the chassis like a line card in a switch. I fit it in, I do not care about anything. So the power management, networking, everything is transported across those copper connections. So I inserted that blade with the mezzanine adapter into my chassis. And as I said, the chassis will not work independently. It has to have a management point above it. That management point is called the fabric interconnect, or FI. So the fabric interconnect is the thing that I really need when I'm connecting blade servers. I can connect C-series server, so I can take my independent C-series servers and also connect it here. That's not going to happen in the lab. You will see this. You will see a blade chassis connected to your fabric interconnect. So again, a blade chassis cannot work without a fabric interconnect. This fabric interconnect looks like a Nexus switch, but it's not a switch by default. So no switch. It is a fabric interconnect. So I connect some cables from my blade system, maybe 2, maybe 4, maybe 1, maybe 8. Up to 8 links I can connect from my fabric interconnect going down towards my blade chassis. So again, if I have a blade that is capable of transporting 8 times 10 gig, on the back plane I only have 8 times 10 gig going to the rest of my network. So it's an oversubscribed system. But as I said, there's not a single system in the world that can transport 80 gigs of traffic. These guys run, of course, in a failover mode. So I need one of the two to be up for my system to be working. And of course for the network to be up. This is called Fabric Interconnect A and Fabric Interconnect B. They exchange everything with each other. So it's not like a Nexus switch in a VPC environment or anything. They exchange everything with each other. Both databases, both configurations are exactly equal. But they are very special. Besides running the networking part, they are also the part where I manage everything from. So on this FI, I'm running what's called the UCS Manager, or UCSM. So if I point my browser to the UCS system, I point my browser window to this Fabric Interconnect. And from the Fabric Interconnect, all configuration is pushed down to the blades, or to the chassis, to the blades, to the cards, to anything. Anything that I need to configure, everything is pushed down towards those from the Fabric Interconnect. So this is a very critical situation. As I said, they are running a manager and they are running the networking part. Now, I want to focus a bit more on the Fabric Interconnects and leave the blades for what we have right now. And I just want to focus on the Fabric Interconnect. Like I said, the Fabric Interconnect, it comes in 2 generations. There's a Fabric Interconnect 6000 series or 6100 series, and there's a 6200 series. Again, going back to our blueprint, we will see the 6248 Fabric Interconnect. Specifically, it's a very specific model there. So we are running the 6248 model. As I said before, it's like a Nexus switch. So this Fabric Interconnect is based on the Nexus 5548 switch. It is actually exactly the same hardware, but it has the UCS Manager chip running. It's exactly the same physical chassis and it has a different color. That's the only difference. The FIs are, first of all, port licensed. So every port that I connect going down to a blade system is licensed. By default, I get 8 ports licensed. And for every port that I add, I need to add another port license. Now they are very graceful. That means that you only get a warning when you connect new ports. So it's not a very strict licensing. So it's graceful. They trust that you purchase the right licenses. So 8 ports are by default enabled. Now how does the FI look? Let's get a picture of it. Very easy. It's just, like I said, a Nexus switch with a lot of ports. So what we see is just an enormous amount of ports. So on the 6248, what we have is we have 32 ports. Because of the name 48, right? In addition, it has a slot available where I can insert a module for an additional 16 ports, of which totals to 48. So 32 and 16 are 48 in total. So that's where the name comes from. But by default, I will see 32 ports. That's also how my system is running. My live system has only those ports 1 to 32. These are special ports. On the Nexus 5548, they are just Ethernet ports. But on the Fabric Interconnect, these are ports that can run multiple Fabric protocols. So they can run a lot more protocols and a lot more control plane protocols to support all the management stuff that needs to go down towards the blade systems. How does it work? Like I said, these will be special ports, but they are using Ethernet encapsulation. So they are running, first of all, Ethernet, right? It's going down from my blade system up to my Fabric Interconnect. That's running Ethernet. And I'm running FCOE because I want to support fiber channel connections from my blades going up to the rest of the network. So I'm running FCOE between the Fabric Interconnect and the blade. I'm not running FCOE directly up to the uplink switch. I'm running the FCOE part, runs between the blade and the Fabric Interconnect. Very important thing to remember, I do not do an end-to-end connection with FCOE. A lot of people think that FCOE is end-to-end. No, it's a per hop based. So I have a fiber channel connection here going down towards the blade system. And that's it. So I'm running Ethernet, I'm running FCOE, and I'm running some other protocols, which we'll talk about in a minute. Now, as I said, these ports are running this protocol. So and as I said before, the version that we're running in the lab, the 2.0 version, does not support fiber channel over an Ethernet as an uplink. So going up to my network, I support an Ethernet uplink, I support fiber channel uplinks, but wait, where are my fiber channel ports? Now there are 2 options for it. I can purchase a fiber channel port expander. So I can insert fiber channel ports in this slot, but what's much more interesting is that I can use all of my onboard ports as native fiber channel port. The Nexus 5548 comes in 2 models. There is a P version and there is a UP version. Now the UP version is what they use to build the Fabric Interconnect with. All right, so coming back to my story, the Fabric Interconnect uses the UP model as its base hardware model. The UP model has the advantage that it can convert an Ethernet port to running native fiber channel. So I can convert any port in my system from running Ethernet and FCOE and all kinds of Ethernet encapsulations to native fiber channel encapsulations. Of course, I need to change SFPs, but that's a logical thing to do when running Ethernet or fiber channel. So I'm running that as my uplink protocol. I'm using that as my native FC uplinks. And those are called unified ports. So there is a limitation on how I configure that. If I want to enable unified ports, so if I want to run some ports being fiber channel, I need to go, the first port that I can configure as a fiber channel port is port 32. That's a design decision that Cisco took. They said, all right, port 1, the left side of my system is always using Ethernet ports, is always Ethernet cables or connecting blade chassis. And the right side is using fiber channel, native fiber channel. So I start configuring with port 32. Now all the ports that I enable for fiber channel need to be connected to each other, meaning they need to be consecutive numbers. So I cannot take port 21 and 32 and make them fiber channel. No, I need to take port 31, port 30, port 29, port 28, port 27. So each port, every time I increase the amount of fiber channel ports, I need to work my way back from the right until the left of the chassis. Technically, I can configure up to 32 fiber channel ports on my fabric interconnect, which is not a very good thing to do because that doesn't leave any room for connecting servers. But all right, you get the point. So working my way back from port 32 all the way back, how many ports do I need for my uplinks? Unified ports. I will show you how to configure that later. So I'm running native Ethernet and native fiber channel as the uplink in my network here. I'm not running FCOE northbound to the network. I'm just using FCOE southbound to the servers. All right. So that's about the physical ports on the Nexus 50 or on the UCS Fabric Interconnect. Coming back to the HA pair. So I have two Fabric Interconnect usually. I can run a single Fabric Interconnect, no problem whatsoever. It's just that I only use half of the bandwidth then, of course, because I only have one path available going out from my server. Fabric Interconnect A and B are usually what you will see in configurations. Now, like I said, they are running the UCS manager. So the UCS manager is the GUI or the XML tool that I use to configure all my blades, all the settings on my chassis. Besides configuring the blades, the UCS manager also configures the networking part. Why do I say it like this? Well, the UCS manager is running in a separate software version, a separate software partition in that Fabric Interconnect. Like I said, it's running in a separate chip or chipset. So I have my networking ports, my fiber channel and my Ethernet ports, and they are being configured by the management chip. So I do not have an NXOS CLI that I can use to configure things. The network part of the Fabric Interconnect is read-only. I cannot configure switch ports on my Fabric Interconnect. I can do that, but I need to instruct the UCS manager to do that. I can read things from it, so I can do my show commands that I'm used to in NXOS. So this part of the switch runs NXOS, just like I'm used to on the Nexus, and this part, that UCS manager part, runs a different type of software, just a Linux box that is running in a different partition on the flash card, running its own stuff, maintaining its own database of configuration, and then pushing things to where they need to go. So it pushes some things towards the network, it pushes some things towards the servers, it pushes things vice versa. Now, because I'm running that database, of course there can only be one guy maintaining that database. So there's always one active UCS manager, and the other is running in hot standby or HA mode. It's a high availability mode, but it's synchronizing things from the active to the HA one. I will never have two managers active at the same time, right? So you will see that if I point, let me come back to that later. So they need to synchronize their changes with each other. What I use for that are two UTP RJ45 cables between the fabric interconnects, between fabric interconnect A and fabric interconnect B. Those two UTP cables are called the L1 and L2 port. So I connect my L1 port on one to the L1 port on the other, and L2 to L2. Because these fabric interconnects always are beside each other or on top of each other, they connect the same server. So they're never in separate data centers, right? I always connect a blade chassis to something, a management point that's inside my rack or either in the next rack, but nothing further. So this is not a multi-data center solution. This is a single data center solution. Just a management pod. So these can be very short UTP cables. And across these two ports there are multiple proprietary protocols running to synchronize those databases, to synchronize states and stuff. But as soon as the active UCS manager dies, the standby takes over right away. That takes a few seconds. So you will not be able to use the UCS manager for a couple seconds, and of course you lose the session and I need to set it up again. But I do not lose traffic for my blades because the networking part, the NXOS part, they are running as independent network stacks. I just have two network devices that allow networking traffic coming from the blades going up towards my network. They are not dependent on each other. So the only part that's being synchronized is that UCS manager part. That is also the only part of the system that is running in active standby mode. So on a data plane perspective, the NXOS parts are active. I can always use both paths that I have to my network to load balance. So all of my paths are available in the network. It's just the UCS manager part that's being made high available. So pay attention to that. A lot of people say, all right, UCS is active passive. No, just from a management point. There's only one manager active at the same time. But my networking is up and running and I can use that to forward my traffic. And again, if one manager fails, that doesn't have to mean that the networking part fails. It can be a software bug or anything or some software related issue that makes the active UCS manager die. And then the networking part can just work like it used to. So very important difference there. So that L1 and L2 port need to be connected to each other. And of course, when you step into the lab, that will be connected to each other. Now, when we start configuring this, I will get the question to assign management IP addresses to my fabric interconnects. In a UCS system, I need to have 3 IP addresses ready for allocating that to my fabric interconnects. So what are those? So I configure my fabric interconnect A, I configure an IP address on fabric interconnect B, and then I need a so-called cluster or virtual IP address. That cluster or virtual address is just one extra address that I can use to always use the same IP address no matter which manager is active at which time. I don't care about that. I always use that third virtual address to go into and connect to my manager. And I always connect to either A or B depending on how they allocated that. So of course A is usually the one that's active, but that doesn't have to be the case. And technically I do not care which one is active. They do not have any other role in the system apart from just pushing configuration to the right parts of the system. I don't care, there's no traffic forwarding that's being diverted or anything. It's just the manager. So don't care if B is running inactive and I need to have, I really want to have A being back again. So it's not a fallback mechanism, it's always a fill over mechanism. If B is running as the active, fine, I don't care. So 3 IP addresses. You will also see that on the high available fabric interconnect, so not the one that's being active, if I open up the UCS manager on the second fabric interconnect, so when I point my IP, my browser to that guy's IP address, assuming that A is the active, you will see that B will not allow you to start the UCS manager. So you will get a warning. Some people say you get redirected, but I never saw that. But you will see that only the active UCS manager is going to be the one that's allowing you to open up the UCS manager software. And then you can start configuring things. So again, my NXOS part, which is also running there, my NXOS part is just a different part of the system, and it's just a coincidence that they're in the same box. So technically, that UCS manager part and the NXOS part of the box have nothing to do with each other, apart from that there is a management connection between them. That's the only connection they have. So very important difference there. And again, I cannot go into configuration mode on the NXOS part. It's only a read-only CLI. I can do show commands, how much I like, but that also means that from a management point, that IP address that I configure here is a UTP port, which is maintained by the UCS manager. So my management port, the Ethernet port that I use to manage the whole system, is maintained by the UCS manager software. So if I do a show interface for that specific interface, show interface management 0, in the NXOS part, it will show as admin down. It will show as down and nothing's working there. And that is because the NXOS part does not own that interface. That interface belongs to the UCS manager. So it has nothing to say about it. It will see some configuration on it, but it will say shutdown state. And a lot of people get freaked out by it and say, all right, the port is shut down. I cannot manage the system. No, you can manage the system. It's just not owned by the NXOS port. So do not trust the CLI when it comes down to the management port. And I have my L1 and L2 ports again.